In this example, we will use the conjugate pairs theorem to find the polynomial equation with real coefficients that has 2 and 1 minus I as roots. Okay, we have 2 and 1 minus I as roots. Because we have an imaginary number here, we know that it has to have another root, which would be the conjugate pair to 1 minus I. The conjugate pair to 1 minus I would be 1 plus I. So because there now are 3 roots, 2, 1 minus I, and 1 plus I know that I can build the polynomial equation with the 3 factors that these 3 roots came from set equal to 0. So if I have a positive 2 as a root, I know that it came from the factor x minus 2. The 1 minus I and the 1 plus I came from x minus 1 plus I and x minus 1 minus I, all set equal to 0. And notice that I put the x minus 1s in their own separate parentheses because when we simplify these, it'll be easier to do that multiplication and the foiling of that process. So the next thing I want to do is, since I have 3 factors, you should multiply them 2 factors at a time. So I'm going to do the conjugate pairs set of factors first. Recall that if you have conjugate pairs, a plus b and a minus b, when you FOIL them, they simplify to a squared minus b squared. So bringing down x minus 2 and now using my formula for the conjugate pairs, x minus 1 times x minus 1 is x minus 1 squared minus the i's squared. And again, I don't have a middle term because when we FOIL the outer and the inner, those 2 terms cancel out, which is why we have 2 terms left. And then we bring down the equal 0. I still need to do some simplifying inside of this binomial. So I'm going to keep bringing down the x minus 2, and now I'm going to work inside this binomial. So squared binomials come from perfect squared trinomials. So x minus 1 squared simplifies to x squared minus 2x plus 1. And note, over here on the side, another note, I squared equals negative 1. So a minus I squared actually becomes plus 1. So I can now simplify one more time because I see that I have like terms. And this expression simplifies to x squared minus 2x plus 2 equals 0. And now I want to multiply the binomial that I have out front that we've been bringing down patiently every step times the trinomial x squared minus 2x plus 2. And the best way to multiply a binomial times the trinomial is to take the first term in the binomial and multiply it by the terms in the trinomial, and then take the second term and multiply it by each of the terms, and then we'll combine like terms. So x times x squared is x cubed. X times negative 2x is negative 2x squared. X times positive 2 is plus 2x. Then negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x will be positive 4x, and negative 2 times 2 is negative 4. And in our last step here, we will look at all of the terms and combine the like terms. I don't have any other term that has an x cubed, so I will bring down x cubed. I have 2 terms that have an x squared, so we'll combine their coefficients. Negative 2x squared plus negative 2x squared is negative 4x squared. 2x plus 4x is plus 6x, and then we have no other constant except the negative 4. And then we bring down the equal 0. So the polynomial equation with real coefficients of 2, 1 minus I, and 1 plus I is x cubed minus 4x squared plus 6x minus 4. So we have taken roots that were given to us, identified the fact that one root was imaginary, which means we had to find its conjugate pair first. We found the product of those 3 factors, and as a result, we were able to find the polynomial equation that contained those roots.